on this Tuesday evening. We've got Mr. Jason Allen with us, who's the co-founder of Mobility Places, and he's going to talk to us a little bit today about AI agents. So he's got some slides to show and some code. Just if you have any questions, there's a mic I think that will pass around. And if you need anything, drinks, food, feel free to flag me, Casey, any of us down. We'll be happy to help you out.
All right.
Thank you.
Thank you. All right, I've got a small request here before we get started. We're going to be looking at a fair amount of source code, so if you all want to be able to see it, you might want to move a little bit closer because this display is kind of tough.
I'm coming up. I'm Mr. Magoo.
All right, fantastic. I can't see anything either. All right, we all good? We all situated? Mm-hmm. All right, awesome. All right, we're going to talk about AI agents today. And before we get started, I've got a small confession to make. When I built this talk, I really built it for me and people like me. For the past 2 or 3 years, I've seen probably 20 or 30 AI talks in Tampa. And there have been some amazing ones, but they've never really scratched that itch I had. And that was, how does this stuff actually work? Like, I hear these big dreams, these big promises about all these amazing things that AI is doing, but like, what does it look like at a more foundational level? So that's what we're going to talk about today. We're going to talk about AI agents at their most basic level, so that when you all go out and have conversations about AI agents, you've got some intuition around how these things actually function. And a part of this, we're probably going to take away a lot of the magic that some people think AI has. And I was talking to somebody earlier, and when I sort of sussed out some of the things that are going on in AI applications right now, it was a little bit like learning that Santa Claus doesn't actually exist, that a lot of this is just kind of smoke and mirrors.
You're lying.
Well, all right, without further ado, let's get this thing going. All right, about me. This is a lifelike portrait that somebody made for me.
Looks good.
If you guys care about anything about me, you can go look at my website. It's got a link out to LinkedIn and GitHub and some other stuff. All right, let's focus on the important things. What are our goals for today? Building intuition around the following. We can't start talking about AI agents until we really understand how LLMs work. And when I say how they work, we're going to talk about at the highest possible levels. Like, we're not going to talk about transformer layers. We're not going to talk about vector space. We're not going to talk about any of that stuff. We're just going to talk about how they function. Then we're going to talk about tools, because you can't have agents without tools. And we're going to learn how they work in conjunction with LLMs. And this is what I was talking about. You know, some of this magic might go away when we get deeper into that. Then finally, we're going to dive into agents. For that, we're going to use the OpenAI Agent SDK. That one's my favorite. I've used a few of them, and I'll tell you why it's my favorite when we get to that. So listen, we've got a lot of experience here. I'm not the AI expert in Tampa. Y'all have probably done a lot of stuff around this. So if things come up, like, share your experiences with us. Ask questions. Like, we're all here to learn from each other. That's what we want to do today. Sound good? All right, let's do it. Let's rock and roll. LLMs, what do? When we say LLM, large language model, everybody knows that. But at the end of the day, they're fancy predictors, right? So we feed in some text, tokens, and then for each one of those tokens, it tries to figure out, hey, what's the highest probability of the next token being these things that I know about? So this is a very simplistic view, but this is kind of critical to understanding how stuff further down the line is going to be. Like, LLMs are not magical. They are fancy word predictors at the most basic level. And they have all these words because they train on terabytes of data, right? We know that. They're absolutely massive magical machines. But in some ways, they're very, very simple. So in this case, you know, the user could feed in the capital of Florida is, and in its vocabulary, it may have Tampa, Miami, Rome, Tallahassee. And it's going to assign a probability to, hey, what's the most likely word to come after is Florida? In this case, well, I was going to say Miami, but it's going to be Tallahassee, right? So it's 0.98. And then for the next word, it's going to do the same thing. Okay, given that the last word was Tallahassee, what's the probability the next word is going to be and? So maybe it's Tallahassee and it's located in the Panhandle. Or it's Tallahassee, but a lot of people think the capital is actually Miami. Like who knows? But at the most basic level, that's what an LLM does. It's a fancy prediction machine. I didn't realize that little animation was down there. That's kind of funny. So sticking with this theme of LLMs, they only do really one thing, and that is they process tokens. You feed tokens into it, and more tokens come out. And there's a reason I picked coins for that we're going to talk about later as well. They can't do anything else. They don't have any memory. They can't reach out and talk to other APIs. They can't spawn off separate processes. They can't do anything. And we don't even know what they're doing half the time inside of the LLM. It's a black box, right? We know that we feed text in and text comes out. That's all they do. I say that kind of hand wave, that's all they do. I mean, they're absolutely amazing, right? But in some ways, they're a very simplistic thing. So we've been talking about tokens. So what's a token and why should you care? So when text is fed into a model, it's actually parsed out into tokens. Call them tokenizers, right? And every model has its own different type of tokenizer. Basically, it splits up the text into little pieces. They average about, I don't know, four characters in size. Those get fed into the model not as the actual letters themselves, but as numbers, and there's an embedded lookup table where it matches it to a vector, blah, 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 blah. But why should you care about tokens? Because tokens are the way that you're charged for usage, and agents can get really, really expensive. So this is really important to think about when you're building these agentic workflows or AI agents is, hey, what model am I using and how much is it per token? So usually tokens are built on both input tokens and output tokens. And for the low-end models like GPT-4.1 Nano, I think it's like $1.50 for 1 million output tokens. I don't know how much for input tokens. That's at the low end. High-end GPT 4.5, that's $150 for 1 million output tokens. And 1 million sounds like a lot of tokens, but I'm going to show you why it's not. LLMs don't remember anything. They don't have any built-in memory. We talk about agent memory all the time. LLM doesn't remember shit. Like, it doesn't have a capacity to remember. The only thing it knows is what you pass into it. Its context window. That's it. And this is what a context window looks like. Now, this is going to be hard to read, but you know, when you use ChatGPT, it feels like you're texting a friend, right? It feels like I'm like, hey Dan, do you want to go grab lunch next week? It sends off a message, and he sends me one message in return. That's not how it works. When you're in ChatGPT and you send a message, it sends that message, but it also sends every single other message that you sent in that session. The entire chat history every single time until you start a new session. And that's why these token counts start to build up and get very expensive very quickly when you're talking about these multi-turn conversations. Because it's not just, hey, I'm visiting Tampa next week, what should I check out? It's all the other stuff that you've already said. And that's how the model actually, I'm going to use the word memory loosely, but that's the context window, and that's all that it knows. So we're going to show this for real here in just a second. So let's do a quick code demo. So we're going to use Python. Hopefully everybody's had some exposure to Python. We're going to use Jupyter Notebooks. If you haven't used them, they're a really, really nice way to do little interactive demos and test out code in Python. And if you've never used Python, spend 2 or 3 hours one Sunday afternoon, do some tutorials, and you'll be a Python pro in about, I don't know, by the end of the day. So let's go through this. All right, so this is our Python notebook. This is our code. We're going to walk through this. We're going to do a lot of this. I may skip over it because it is kind of hard to read this on this screen. It takes a while to kind of think about it, but we'll do a few of them. So first bit in our Python script, we're just loading some packages and some environment variables. Now we're going to do a single call to GPT. So this is akin to firing up ChatGPT and entering a message, right? Except we're doing it via the SDK, via the API essentially. So in this case, I say, hi, my name is Jason. It says, hey, Jason, nice to meet you. How can I assist you today? Okay, great. Clear all these outputs. Now, if we call it again, we might think intuitively, hey, it's going to remember our name because we just told it, but it doesn't. Because of the reason I just mentioned, because we didn't feed in the chat history. So in this case, we're going to do it again. We're going to say, hi, my name is Jason. But in the follow-up message, we're also going to pass in the first message as well. So this is a way of feeding in our chat history. In this case, it's actually going to know it. Hi, my name is Jason. Easy breezy. So that's how that works. Any questions about that? Makes sense? All right, cool. Let's keep going. All right, tools. Tools are awesome.
I just have one question on that.
Yeah, go ahead.
How back in time does it go usually?
It depends on the size of the history that you feed into it. So I guess you can exceed the context window and it'll just truncate anything older than X, but the context windows are pretty big these days. The Google Gemini is up to 1 million tokens, context windows. But again, it's going to get very, very expensive. So you want to chop off those conversations as soon as you're done talking about one topic before you move on to the next one. All right. Tools, also called tool functions, function tools, something, whatever. A million different words, but they're all the same thing. Anybody can tell me what these are and how they work? No? All right. So we mentioned earlier, let's go back to our LLM. It's a black box, right? We feed tokens in, we feed tokens out. It doesn't know anything else except the data that it was trained on, which is usually 6 months, a year, 2 years, 3 years old. That doesn't help us if we're trying to answer current questions, right? That doesn't help us if we're like, hey, what's the weather today in Tampa? It doesn't know. So a couple of years ago, OpenAI came out with this notion of tools or tool functions. And that is a way of kind of working around this limitation in the LLM. And this flow is, I'm not going to lie, it's a little complex, but it's worth understanding. It's worth knowing because this is so critical to how these agents work. And the tool usage for LLM has, I think that's probably been one of the biggest things that's progressed in the last year, honestly. I mean, the models have gotten a little bit smarter. They haven't got a lot smarter, but their ability to leverage these tools has gotten dramatically better. So what are tools? All right, so this is kind of nasty, but bear with me, please, and you'll be thankful you did a thing. So here's the original message that we had. You saw this in our last Python notebook, right? So with a tool, you're going to pass in some other stuff. You're going to pass in this nasty JSON. And what it's doing is it's saying, hey, Mr. LLM, guess what? I've got this thing. This thing is usually a function call. And this thing has an output. In this case, the function called is getWeather, and it's going to allow you to get the current weather. So, Mr. LLM, if you want to, I can call this if you ask me to. Now, one thing to know is the LLM cannot directly execute code in your application. It cannot do that. It's absolutely impossible to do that. But if you build an interface like this, and you have a function that executes code, then the LLM can say, hey, please run your code, or please run the code that I give you. Let's go through this flow a little bit more. So here's the complete flow. We're going to go through this one more time. So we've got the developer, we've got the application over on this side, we've got our LLM, we've got our model on this side. So the first thing that we're going to do is we're going to say, hey, what's the weather in Paris? Along with that, we're going to pass in, we're going to tell the LLM, hey, we've also got this function that you can use to get the weather. So the model's going to say, hey, based on the question that the user just asked me, hey, I want you to call your getWeather function for me. So your application is going to run this getWeather function. It's going to say, hey, the temperature is 14. Hopefully that's Celsius, not Fahrenheit. And then it's going to pass those results back to the LLM. It's going to say, hey, Mr. LLM, I ran the function that you wanted me to, and here are the results. In this case, it's temperature 14. It's going to take that along with this original question, and then it's going to pass this final response back to the user. And that is, hey, it's currently 14 degrees in Paris. If you get nothing else from this, please remember the model, the LLM cannot execute code. It can only ask your application to execute code. That's fundamental. So let's go through another demo of this. Is everybody following this so far? I just want to make sure.
Good.
All right, good. All right. All right, so same sort of thing. We got some imports up at the top. We don't really care about that. So let's ask GPT-4.1, hey, what's the weather in Tampa right now? I'm unable to provide real-time weather updates. And why is that? Because it can't reach out to anything. The only thing it knows is the data that was trained on and the data that you pass in it via the prompt. Now we're going to define our own weather function. And this is just a generic old Python function. This one's mocked up, obviously. I mean, if this was real, you'd probably want to reach out to an API somewhere that could give you what the actual weather is. But we're gonna mock this up. All right, then we're going to build this nasty schema that's going to tell the LM, hey, we've got this getWeather function. Call it if you want. So now we're going to make a second call to the model. And this is the one that's going to tell it that we have this function available. I forgot to run this one. There we go. So this is kind of a weird response, right? This is not a, hey, I can't get the weather. It's this other thing. So this is where the LM is saying, hey, Mr. Application, would you please run this function that you told me about? And here's the arguments that I want you to pass into it. So, okay, we can do that. Now we're going to run the local function ourselves. Again, we're running it, not the model. But we're going to save that result that we got from the function. Now we're going to call the model again with our chat history where we ask what the weather is and with the output of our getWeather function. All right, the weather in Tampa is sunny and 70 degrees. Boom. Sir, you have to.
It's
You have,
94, by the way.
yeah. Sorry. Where's the mic?
Right on. All right, I might eat it. No, just kidding. All right,
you got?
so the question is it referencing the known temperature that it saw on the list that it saw submitted earlier, or is it referencing the tool, activating the tool to pull the to go ahead and pull that information down?
No, the information it's referencing is going to be an output of the function when the function
Of the function.
When the function is executed locally.
When that function is executed locally, which you executed,
Correct.
The LLM did not go ahead and execute the function.
Correct.
Okay.
Bingo.
All right, thank you for that.
Yeah.
Anybody like a taste?
Any other questions? All right.
So this is all using your SDK.
This is using the OpenAI. This is the chat completion SDK. Yes. We're going to get into the agent SDK here in a few minutes, and it's going to be a lot cleaner, a lot nicer. All right, here's basically the same thing. I'm just going to run all this all at once. Gradio is actually a nice little tool if you all haven't used it. It's a UI package that's developed by Hugging Face. Hugging Face is basically the GitHub of AI. But it's pretty cool for running quick and dirty little chat interfaces. And we're going to see how this works. So again, this code's basically the same as what we had on our, I should have done the light skin with this. On the previous demo, it's just now that we have it in a nice little pretty interface. So we can do things like, again, what's the weather in Tampa? This one's a little bigger. Okay, great. But since it's going to an AI model, you can ask it kind of smarter questions, right? It's not just, hey, what's the temperature? You can say, do I need a jacket in Tampa? May not need a jacket. Okay, great. So what about London? Do I need an umbrella? So it doesn't have current data weather for London because that wasn't part of our little mocked up get weather function. So it's working exactly as it should work. For the information that it's able to get from our tool, it gives it back to us. For information that it can't get from our tool, it says, hey, I just can't answer you, which is what we want it to do. All right, what we got next here? Oh, so the last talk that we had here, which was an awesome talk, we talked about MCP a lot. Right? That was a buzzword du jour, right? Model Context Protocol, developed by Anthropic. MCP basically bundles up a tool function into a package that can be redistributed or hosted somewhere else. It's got a few extra things. So they have this notion of not only tools, but prompts and resources as part of MCP. I've never seen that used. Maybe somebody somewhere is using it, but basically it's just packaging up these tools so that you can reuse them. If you guys are interested in that, there's a bunch of sites out there that have MCP things. So these are cool because you can get pre-built MCP servers for things like Salesforce or Gmail or any sort of common business app these days. So you don't have to write it yourself. So a lot about MCP under the hood, basically just tools. All right, agents. Finally, we're going to talk about agents. Agents are collections of things that you just saw, basically. They're not much else. It's a call to an LLM. Well, I skipped our proper definition. I'm sorry about that. There's a lot of, I don't know if any of you are on Twitter these days or X, whatever you want to call it. There's a lot of religious wars around what's an actual AI agent. So this is OpenAI's definition. Agents are systems that independently accomplish tasks on your behalf. Me personally, I don't care what the definition is. To me, it's using AI in a non-interactive way that accomplishes something useful. To me, that's my definition. But you all may have your own definitions, and you're probably right. But that's the strict one. So this is from Anthropic, and this is kind of what they call the anatomy of an agent. Right, so the middle, we're going to have our call to our LLM, which you just saw. We're going to have tools. We're going to have a call response. We're going to have a query result. So this could be any number of things. It could be like some sort of RAG setup. You could query your business documentation or something else. Maybe do a SQL query on a database. Then read write. We're not really going to talk about memory, but for long-running agents or agents that interact with end users like customer support, like you probably want to store some specifics about that individual or about that session for long term. So for example, so we use AI agents for our customer support. So if a user, is upset about a situation, right? So we're going to make a record of that in the AI memory. Or if we've had payment issues with that customer in the past, we're going to store that memory, not for the customer, but for us. So we know when we deal with that customer, like, hey, we've had a hard time getting this person to pay on time. So it can be very, very useful, but out of scope for this conversation today. So what are some of the real world use cases around AI agents? I mean, it's this thing that's been hyped up for so long. It can solve all the world's problems. Where is it actually being used right now? I think software development is number one. I don't know if any of you have used Cursor or Windsurf or I forget what the Microsoft thing is. I've been using Cursor every day for the past year to develop software. It has gotten exponentially better. Maybe not exponentially, but it's gotten dramatically better. So when I first started using it last summer, the autocomplete and the AI agent or AI code authoring, I estimated it saved me about 30% time, or made me 30% more productive. I would say at this point, it's probably up to 75 to maybe even 80%. Every time I go in there and I start developing on something, dude, I feel like a little kid. I feel like I'm living in the future. I mean, this thing has gotten so freaking good. And a big part of that is because it's gotten really good at calling tools, which is what we saw earlier. That doesn't mean it's perfect. It makes a lot of stupid mistakes. And I'm a little bit embarrassed to say I do cuss at it sometimes, but only when it's being really dumb. Customer support. So again, my company, we don't have a live phone agent. We have an AI agent that answers the phone. It sounds pretty good. It's not perfect. So for customers who can't find their parking, for example, it's going to go reach out to our back end. It's going to make a tool call and say, hey, give me the parking information for 110 Van Ness in San Francisco. And it's able to give instructions back to the user in real time doing that. We found that works out really well. Phone AI agents in general, chat's better, but our customers, they want to talk on the phone, so hey, that's what we do. But these things have actually gotten really, really good for tier one type problems. The other one is marketing. I mean, you all have seen this, whether you know it or not, right? I mean, half the marketing out there is probably AI generated at this point. Huge use case. I did some searching on Reddit to find other like real world use cases as well, some specifics. And this is what I came up with in my 15-minute search. And these things are all kind of similar in the way. I mean, a lot of this is either text generation or collection or summarization and or classification. And I think those are things that these models and these agents are really good at. There's a lot of stuff that they're not good at, but anything like this is probably going to be a win.
These are all efficiency things, right? It's driving huge efficiency across the user.
That's exactly right. I'm going to give you my own example. I don't know why that's moving like that, but it is. This is a little pet project I'm working on with some buddies of mine. It's a little micro SaaS site. And reason I'm talking about this one is because I want to show you all how I've got the back end working. So the basic idea is with ThreatWatch, it's for cybersecurity folks. It's like an alternative to Google Alerts. You go in there, give a little bit of information about yourself, like your role, your company, and then some keywords you want it to monitor. And then every morning it's going to send you an email with any relevant news about those keywords. So it could be like, I don't know, Palo Alto or Fortinet or Facebook data breach, like anything you want. But I wanted to have an agent workflow on the back end wherever possible. And agents don't make sense everywhere, right? So the whole thing is not agentic, but there are pieces of it where it really does make sense. And I thought this was a good example of a use case. So we've got the user keywords, and we also have some user context, right? So we know something about this user. We know if they're a CISO versus a security engineer. So each one of these steps, it takes that in consideration. The first thing it's going to do is going to search the web every night. Hey, are there any new Fortinet vulnerabilities? If so, we're going to scrape any information about that, and then we're going to summarize it. But the agent isn't summarizing it the same way for everybody. Again, we're pulling in that user context. So we're saying, hey, if you're a security engineer, a security analyst, you're probably going to want a lot more technical detail than if you're a CISO or if you're on the executive side. And so that's what it does. It figures out, hey, do I want this to be real concise? Do I want it to be wordy? Do I want it to be super technical? Do I want it to not be? So then we collect this, each one of the summaries of the keywords, and then we just kind of do a roll-up. So a summary of a summary, if you will, sort of a meta summary. And again, that's where that user context comes into play, so we can personalize that output for that particular user. And I think this is a really good use case for agents because they are making decisions, they are doing useful things, And they're things that you couldn't easily do with traditional software. I mean, you might be able to do some of this stuff, but it's going to be freaking hard, and it's not going to be as good with traditional software approaches. So I think this is an awesome way to use agents. Now the downside, and the thing that I'm a little bit worried about, is the cost. Because we talked about those tokens, they add up, right? And if you're doing this at scale, it starts to get very, very expensive. So we're going to keep an eye on that. All right, agent frameworks. So say you want to start building your own agents. As I mentioned before, we're going to look at OpenAI Agent SDK. It's my favorite. There's a bunch of them out there. Microsoft's got some. I don't know if that's the right one for Microsoft. Is anybody Microsoft people here know? That's the right one? Okay, great. Small Agents is Hugging Face. It's another sort of micro framework. LangChain, LangGraph is probably the most popular one. I'm not a fan, and here's why. That framework abstracts too much out. These things become really hard to troubleshoot in the best of times, and if you're looking at things through 3 different layers of abstraction, it becomes freaking impossible. A lot of people like it. I don't. Crew AI is pretty cool. It's probably most similar to the OpenAI one, but there's a bunch of ways to get started with this. So let's do another agent demo. Any questions while I'm pulling this up? Everybody still awake?
Yes.
All right.
Definitely still awake.
All right, good. All right, so we already know this first bit. We're going to load our libraries. Dude, this is how easy it is to create an agent. It's literally 2 lines of code. It's awesome. First line, we're going to define our agent. This one we're going to call joke teller. And we're going to give some instructions. You make people laugh. And then maybe we're going to tack on some additional information like what model we want to use. The next line, we're going to run it. That's it. 2 lines of code. It can't get any simpler. It's amazing. So with this, it is very simplistic. We're basically doing what we were doing in the previous Jupyter notebooks, but just with a lot less code. So let's run this and see what it does. All right, can somebody read that for me?
Why did the AI agent break up with this human? Because it found their logic too emotional to compute.
All right, so maybe it's not the best joke in the world, but it's a joke. All right, so this is one of the design patterns. This came from Anthropic, by the way. It's a very common one, right? It's probably the most common one. Chain multiple agents together. So we run an agent. Its output gets fed as the input to the next agent. That's what we're going to do right now. So with this one, we're going to define 2 agents. We've got our joke teller, and then we've got our critic. The joke teller is going to tell us a joke, and then the critic is going to tell us whether it's funny or not. So we're going to ask the joke teller to tell us a joke about Ybor City, because that's where we are. And then the critic's going to run, and it's going to tell us whether it's funny or not. I'm not sure what's going to happen. Hopefully it's a little better than the last joke. All right, where we go? Here we go. Who wants to read this one? Don't be shy. Somebody.
Why don't ghosts haunt Ybor City? Because even the spirits are afraid they'll get rolled into a cigar.
Well, let's see what the critic says. It uses 7 out of 10. I think the critic's being generous on that one. I would probably give more like a 4 out of 10, but maybe more critical. It's clever and contextually rich, but somewhat niche, making it less accessible to the general audience. Well, yeah, that's a nice way of putting it. All right, so one thing that we didn't talk about that's pretty cool is this with trace. So I mentioned earlier these agents are really hard to troubleshoot. But a nice little thing that OpenAI gives us with their SDK is some observability, and again, with a single line of code. So now we can go out to traces, and we can see what just happened.
Yeah, so how do you give it feedback to say, I thought that was a 4 out of 10, versus it gave itself a 7 out of 10. Can you do that? So that wasn't really that funny.
You can. There's a couple of ways to do that. So probably the way that comes immediately top to mind is that you would have multiple critics. And then you would just take, I don't know, take the average of those critics maybe, or maybe you would have one critic where the instructions you give it are a little bit softer than another critic. You could tweak it that way. But having multiple judges is probably the way that I would do it. All right, so we've run a bunch of these when I was testing today, so ignore those. But this is what we get. We get this for one line of code in OpenAI. So this first one here is our agent, our joke teller agent. This is the request that it made. Here's the system instructions. Here's the input, and there's the output. Now, guys, this may not seem like a lot when we only have 2 agents, but I'll tell you what. You got a dozen agents, and each one of those agents are making tool calls, and maybe those tool calls are actually agents themselves, and they're calling other tools. Like, this stuff becomes really, really valuable. So this is our critic. And remember, we're taking the output of the first agent, and we're passing it as input to the second one. So the input should be our joke from the first agent. There we go, boom. All right. Make sense to everyone? All right, let's keep going. What we got next? All right, this is probably one of my favorite demos, just because like I've been in this situation so many times. I thought how cool this would be. So this is an agent routing pattern. So the idea is that you have one agent that decides which other agent to send it to. So if anybody's ever worked on a help desk or had to route work from one department to another, you'll get the idea of why I like this so much. So we're going to find 4 agents: billing support, tech support, default, and our triage agent. So our triage agent is going to be the one that we call initially, and it's going to hand off to one of the other agents. What does that mean, hand off? Basically, it's going to hand over flow control of the rest of the application to one of these agents, and it's going to decide what to do with it. In this case, we don't do a lot with it. We just print something out, but you could route tickets very easily. You could shoot off an email to a certain department. You could even try to answer questions. I mean, this is an extremely common use case, and this is a really cool way of solving it. Because, again, like if you've ever worked on a help desk or you've gotten tickets in from somebody, it's usually just a blob of half-baked text. So you're not really sure what the heck it is, and we can have the AI figure out who to send it to. That's awesome. All right, so let's run this real fast. The problem we're having is you overcharged me for my last bill. I'm sorry to hear you were overcharged, but the important thing is that, not the output in this case, but the fact that it was able to figure out, the triage agent was able to figure out that it's supposed to go to the billing support agent from these 3 agents. That's the cool part of this. Now, what you do after that, up to you, but it's handling the routing portion of it for you.
Is it because it's so the word billing?
Well, let's go back and let's see. Hey, you overcharged me for my last bill, so let's run it again, see what it does. Yep, went to the billing support agent again. Yeah, maybe a typo on it. Yeah. So it seems to be doing what it's supposed to do.
Billing association, words associated with billing inferences.
Right, which is one of the magic things of LLMs in general, right? It understands context. right? Better than anything, any sort of traditional data retrieval or programming approaches. That's the magic behind it. All right, I think we just got a couple more demos here. All right, tool calling with agents. Let's run this one real fast. We're not going to spend a lot of time on it, but we have talked a lot about tools. Tools with agents are even easier. In this case, we're pulling in a tool from a script here, but it's the same thing you all already saw. But we're going to introduce a new type of tool. So again, this is specific to the OpenAI SDK, but I think the other ones have this too. So it's this idea of hosted tools. So OpenAI itself can do web searches. If y'all have used ChatGPT in the past few months, you know that it does web searches automatically. So the back end is just doing some sort of tool call. But they've exposed that via the SDK, so you can do that now. It's got a handful of other built-in functions too. It's got a code execution tool and some kind of RAG tool as well. I haven't looked at the other ones. The web search tool is the only one I've looked at. It works really well. Here's the downside to this though. Like all this stuff, the web search tool costs 2.5 cents per call. Again, doesn't sound like a lot, but you scale that up, it's going to get pricey. And it gives us real-time results. All right, so June 10th, 2025, I assume that's UTC time, 92 degrees. Somebody said it was 93 earlier, so we're pretty, 94? All right, well, we're close. So it's getting that from the web somewhere. I don't know where. It doesn't tell us, but that's what it's doing. All right, guys, we have one more demo. Y'all have held in this long. It's been a lot of code to look at. I appreciate y'all sticking with me. This is a big one. This is kind of combining a lot of the concepts that we talked about earlier into something a little bit more grand, useful. I don't know. Actually, you know what? I want to show you all what it does before we dig into it. So we're going to do a deep research collection of agents, we'll call it. We're going to have 4 different agent types. We're going to run 3 agents at the same time. And this is actually kind of similar to the threat watch flow, but the use case is very, very different. So what the planner agent is going to do, given the query that we pass into it, it's going to come up with queries for web searches. And the query that we're going to give it, we're going to pretend it's a biz dev person working in a staffing firm, and they're looking for companies who want to hire cybersecurity experts. So given that, it's going to come up with some number of web searches. The search planner is going to feed those into the search runner. It's going to search the web. It's going to come back with the results. The report writer is going to aggregate and summarize those results. It's going to hand it off to the email agent. Email agent's going to make a nice report for us, and everything goes well. We're going to get an email in a couple of minutes with what it actually did.
Can I ask you a question?
Yes.
So this is something I've been thinking about with AI. When you go and you ask something and you think it's going to go crawl the web,
Yep.
what is it crawling? Is it crawling? Is there like some kind of interface with Google that's happening, or like what is being crawled? Like how do you promote your business? Is it through like if I go buy a bunch of Google ads, right, or LinkedIn ads? Is it going to know that if you're looking for cybersecurity, which is what we do, right?
Yeah.
How's it going to know to find Ballast versus another company? How's it know that? Because I look at Google search engines different,
Yeah.
but is it integrated somehow?
It's a very good question. So there's a couple of ways you can do that if you want to build your own agents that do web searches. The easiest way is to use the built-in, the hosted web search function, which is what we're going to do in this playbook. There's also a couple of APIs out there that's basically, I don't know exactly how they do it, but they do Google searches on your behalf, and then they'll return results to you in a nice JSON format. Those are actually pretty inexpensive, and that's what a lot of folks are using to do things like collect all the products off Amazon and whatnot. Right. You know, in terms of what is OpenAI doing, I don't know, honestly. I think they have their own web spiders, their own scrapers that are going out there and basically collecting everything on the internet. And I say that because I remember reading something not too long ago where you can see whether the OpenAI web scraper, whatever you want to call it, has visited your website because you can see it in your logs. They have a user agent string in their logs that you can see.
So that was a discussion I had with our marketing guys. Like, should we do Google Ads, or is that even a thing of the past? Is it just going to scroll itself versus interface? Sounds like we don't know yet.
I don't know. Maybe somebody else. All right, we're going to start this thing off because this is going to take a couple of minutes to run. I'm just going to zip through it because there's a lot of stuff in here. So let's start at the top. So this is defining what our search agent the prompt for that. Remember, we're going to have 3 of those run at once. We're going to use a web search tool from OpenAI. We're going to use a high context size, so it's going to collect more for us. We're going to perform the search with a single agent. This is just a test. So the idea is we're going to identify companies headquartered or have a presence in Tampa that are looking for cybersecurity professionals. Because remember, we're a staffing firm. We're looking to expand our business into companies that are hiring for cybersecurity roles. So here's some of the ones that found with a single search. So if we put all the searches together, we're going to see what it's going to do. So this is the search planner. This is coming up with the queries that it's going to use for its web search. So largest tech companies headquartered in Tampa. What's the other one here? Query Tampa companies cybersecurity hiring news 2024. Well, it's 2025, so I got that wrong, but okay. We're going to define a new type of tool this time. It's going to be send email. In this case, we're just hooking into SendGrid using their API, piggybacking off that. But it's going to be the thing that actually emails us the report. It's just a little test function I set up. Our email sending agent. So this is giving instructions. Hey, format the email, make it look pretty before you actually send it. This is the thing that's actually going to write the report for us. So notice this, it's a little bit out of order in terms of execution, but you get the idea. We got some wrapper functions that are actually going to run those agents that we just talked about. I'm going to send it, and
This is all
cursor.
cursor?
Cursor is the IDE, yes, but
Right.
this is all Python and Jupyter notebooks. But yeah, we are running it out of cursor.
Out of cursor.
Yeah, but VS Code is exactly the same thing. All right, it claims that it's done. Let's hope so. This actually didn't work a couple of times today. I think OpenAI was having some problems with their API, or they were down for several hours today. All right, here we go. Boom, we got it. 719. Yep. So this is the report that we just generated. Cyber Florida, security staffing lead, identification and market analysis. Tampa cybersecurity sector is undergoing rapid expansion. Staffing market overview. Cybersecurity roles expected to rise by 14%. Sounds reasonable. Skill gaps. All right. Lead identification, segmentation, Mosaic, Bloomin' Brands. Maybe. High growth tech firms, ReliQuest, DeepWatch, Abacode. Okay. Buy that. Then we got a nice little table down here at the end. Staffing drivers. Oh, this is actually pretty cool. Compliance, reach that, HIPAA. Competitive landscape, yep, got that one. K4's Tech Systems. All right, then it tells us what to do. Here we go. Target CISOs, yep, we know that. Applied talent mapping. Differentiators. Oh, it's got some nice links for us. All right, so we did all that in like 50 lines of Python. I don't know about you guys, I think that's pretty freaking cool. I think that's pretty cool. And this is like something that actually be useful. I mean, you could have this kickoff, you have to tweak it a bit, but kick it off like once a week or something for your biz dev folks, or you can have it run any sort of like deep research type report you want it to. Yeah, absolutely. Absolutely. All right, so what's the downside? Let's talk about the downsides. There's always a downside, right? Nothing's free. Agent challenges. They are myriad. They are amazing, magical things when they work. But they can be really hard to get to work, and they can be really hard to keep working properly. So let's talk about some of the biggies. Non-deterministic, what does that mean? Yeah, you can run the same query or prompt twice on an LM and get completely different responses, right? You just don't know. And that compounds when you're running these agents where you're basically chaining these things together or you work with them in tandem. You often know what's going to happen. Now,
can that be mitigated by modifying temperature setting?
yes, that's absolutely one way. And then there's another way as well that we didn't talk about today, this thing called guardrails, right? And I think all the frameworks have this idea built in. So it can look at both the inputs and the outputs and say, hey, this thing is out of bounds. And what do I mean by that? It can have regular expressions and say, hey, if the output doesn't say, I don't report in it, then throw an exception, throw an error at that point. And the same with the inputs. If you had a support chat agent and you didn't want people to input profanity, for example, you could have a guardrail up there to match on profanity. It's just going to throw an error if anybody says any bad words. So yeah, there's different ways of mitigating this for sure. Is it bulletproof? No. Hallucinations. Sorry, go ahead. Yeah, take the conch, please.
I had another question on that one.
Yeah, sure.
So one of the challenges, so I had the AI experience where the output was really good. Then we did an update to the model and the output was not good. And so what I learned from that was like, okay, I don't want my prompt's already gotten longer and longer. But at what point, if I see something I like, do I have to like essentially hard code via prompt? I'm just saying hard coded, but you have to specify, I really like this, keep doing this every time, because then it feels like I'm being too specific and too rigid, and then it's going to create a problem or lock myself into a current model. So I'm curious, like, how do you handle that? Like, I like that, I want it every time. How do I have consistency? Because these outputs are now our products.
Constant change. I think I misspelled that. You're absolutely right. I mean, the models are constantly changing, right? And you don't want to be using the old model because they get deprecated and eventually fall. So, how do you resolve for that? There's a couple things. So, we didn't talk about a bunch of things today, right? And one of the things that we didn't talk about is evaluations. So, running these prompts through evaluations to see which one gives the best results over time. But you said, okay, like we've got it dialed in. We ran our evaluations and we upgraded our model. Now we're getting shitty results. It's tough, right? I mean, there's a couple of things you can do. Neither one of them are particularly attractive unless you're a pretty large company. And one is like run your own models. Like take an open source model or fine tune one of the existing models and train it on your own information, on your own prompts, so that you're generally going to get better outputs. Related to that is reinforcement learning. So hey, yeah, these are known good outputs for this given prompt. Again, another idea of like fine tuning the model. But there's no easy answers to that at all, and that's one of the downsides to all this, right? I mean, that's one of the things that, unless you want to get deeper into fine-tuning and/or rolling your own models, yes. But if you come up with another idea, let me know, because I'm very curious about that one. But that's the thing with this stuff, right? People still trying to figure it out. I mean, like, we didn't know anything about even tools like 2 years ago, and now it's like one of the core concepts around LLMs and agents in general. Sorry, we have another question?
I'm just curious, are models versioned? Because they're always changing, right? So when they're trained on a particular data set, does it get a moniker like, oh, this is 2.0?
Yeah.
And it's always done. I mean, every model does that. Is that what you're saying?
Yes, yeah, and they are versioned, but they also get deprecated pretty frequently as well. So,
Well, but to answer his question, so if he were to pass in a version number of the model he chose, would that work? or is that too much?
But he said he wanted to upgrade his model because presumably the new model was smarter, I would assume, or cheaper, or both. Yeah.
It's now better after
Yeah.
working through that.
Yeah. Yeah. So it's
So one way would be stick to a model if you don't need to change. If you do need to change, you just got to go through the eval process.
That's right. Stick to a model, and if you're worried about being deprecated, I mean, you can always run your own models, right? You don't have to use these APIs from the big vendors.
What we're doing would be to take an existing model and then give it some context of your own. So it learns from that context.
Yes.
So it adds to it effectively.
Yeah, but I mean, you're basically doing what you just said, and that is tweaking the prompt, because that's what the prompt is, right? I mean, it's just the context you're feeding into it.
I would lean on the side of like being very specific, like with the prompts as far as like, I want this done this way and creating rules around that, because I just think forward in the future, they're going to get better and better, and it's going to be able to say, hey, you told me to do this every single time. However, we have the option of doing it this way. You know, I mean, like, that's going to happen, you know? So I think to rely on like expanding your prompt and providing more specifics is probably like looking at like your expected value on like what the outcome is going to be. I would say lean on being more specific and dealing with that.
Every time it's wrong, you have to feed it back in, so it's learning from its mistakes.
Yeah, but if you're using cursor and stuff like that, I mean, you can create rules that are very specific, that are like, this is when you do these types of things, this is how I want it done.
Yes. But there's a big but in there.
Yeah, what's the but?
The but is the models will just ignore them. So, not all the time, but very frequently. Here's a pet peeve of mine, right? So, I've been doing this development in Python recently. So the kind of old school quintessential way of managing Python packages is through pip, like pip install whatever. There's a utility that came out about 6 months ago called UV. It's amazing for managing Python packages, 10 times faster than pip. It doesn't matter how many times I tell cursor, how many times I have in the rule, don't use pip, use UV. Like, it'll ignore it probably 40% of the time. So, and there's different reasons for that, right? So, you know, cursor claims that it's passing in these rules during every single query to the, maybe it's not, maybe it's just leaving me out. Maybe there's too much context in that context window that the LLM's processing through and just ignores it because of that. So there's different reasons, but I mean, what you're saying is absolutely reasonable.
Right.
And
right. I just look at it like that will get better. How do you manage that now? Like those inconsistencies. Like, what's your like human guardrails around that?
I cuss at it very loudly, honestly. You can't see. I'm never going to show anybody my chat history in Cursor because it's full of profanity. It's like, why are you so stupid? But it's. I say that a little bit tongue-in-cheek, but not completely. But it's trying to tweak the Cursor rules to say, hey, don't ever use pip in all caps. Always use UV, but it only gets me so far.
Do you have a writing unit test?
No. No, actually, no. I take that back.
Where it's checking itself?
No,
Okay,
no. I do have it writing some of the feature tests for my apps. It's pretty decent at that, but not for its own outputs. No, I don't. Hey, go ahead.
Kind of to answer some of Jody's stuff as well. On the slide before this, where you kind of showed the workflow of the email piece of it, it's the benefit of having all those different agents that are, to your point, right? The agent, it doesn't follow the instructions exactly to a T. How do you maintain it? You want to update it. What part of it do you want to update? And so by having a bunch of agents that are specific and this is what you're responsible for,
Yes.
it's easy for you to maintain, scale, and debug it easier, right? Because, hey, my problem is it's not sending good emails. Okay, well, I don't need to write the whole thing. I just go after the email agent, right? And you handle it that way.
Yeah, that's absolutely right. And you know, with these agents, I mean, if there's things you can do with traditional coding techniques, it's probably better to do it because you're not going to have all this crap to deal with, right? It's going to be deterministic. It's going to run the same way every time. The agents are really useful when it's making some sort of judgment call, like, hey, what's the best text to extract from this web page, or who should I route this thing to? That's where these things really, really shine. Or write all my source code for me. They're pretty good at that. They're pretty good at that. Not great, but decent. All right, what else we got?
On this point of liking and disliking a response, just curious, like thumbs up, thumbs down, that's like a built-in component in a lot of these models. How do you best tell it the good thing versus the bad thing? Like in the old world of machine learning, right? Here's my 1,000 good ones, here's my 1,000 bad ones. What's the best way to keep that up to date?
I don't know how those guys are doing reinforcement learning, honestly. But if you're interested in that, there's some good prompt eval frameworks that basically do the same thing. So it allows you to tweak your prompt, and you can do things like create unit tests on the output, or you can just grade it from like 1 to 10 or give it a thumbs up and thumbs down. So that's actually a nice way of developing your prompts and seeing how well they perform in different models. All right, what else we got? All right, the future. I wish I could predict this one. Honestly, I don't know where we're going. The past 2 years has just been incredible in terms of the power and the adoption of these things. And again, the models have gotten smarter, but to me, the sea change has been the model's ability to use tools to go out there and get information from other sources and do things with it. What do y'all think? I mean, where are we going to be a year from now?
Well, MCP was pretty quick in your presentation. I mean, I feel like that's the game changer, where you get more communication across different models, and it's kind of like what happened with the API not too long ago. I feel like that's the API for AI, is essentially like being able to glue all these things together. I think that's to me like the future, and is more recent.
Yeah, that's what I mean by the tools taking off. And I agree with you absolutely. Yeah. That's the big sea change right now, and a lot of the MCP servers are honestly just light wrappers on top of an existing API, for better or worse. But yeah, that's going to continue to evolve. That's going to get better. Absolutely. What else? Somebody had mentioned something about replacing barbers earlier. Yeah.
Yeah, I think a lot of the stuff we hear on AI, people talk about, it's just they have no clue really what this is.
Yeah.
It's like there's a lot of speculation about capabilities, but after looking at this and how it really works, I think it's got a long way to go.
Yeah.
I think we're not even halfway yet.
Yeah.
Not even halfway. Did y'all read? Did you hear about that paper? I haven't read it yet, but Apple published a paper a couple of days ago, and it was basically, hey, these reasoning models that y'all been talking about, like DeepSeek and O3 rather, they're not really reasoning. It's just all pattern recognition.
Right.
So
Most of AI is pattern recognition.
yes.
Are you sure that reasoning isn't pattern recognition?
Well, that's the counter argument, right? It's just like, well, are the LMs really thinking? Are they really reasoning? Well, do we even understand how humans really think and reason at this point? Maybe it's the exact same thing.
So I'll just tell you this anecdotally. I got a little AI group, but there was a professor at USF. He pointed me to a friend of his that wrote a paper that said GPT-4 doesn't reason.
Okay.
And it's the most amazing thing because the depth of which he wrote the test cases, it's like, how does your brain even work that you found this test, like this complex math and all this stuff. He wrote that, it's less than 2 years ago. He found 23 ways that GPT-4, and I don't know if you remember when GPT-4 was released, Jeffrey Hinton left Google and said, man, this thing's going crazy. We need to stop all of this.
Yep.
The world's about to die, or like he was so worried about it. Respect Jeffrey Hinton, everybody does, but at the time he wrote this thing, and it was 23 examples. All 23 examples can be solved by every model now. he said GPT-4 can't reason, gave 23 examples of how it couldn't reason. You can find it, Constantine, I don't know, you can find GPT, it's a white paper on Archive. You can find it. All of the models solve it now. So I just, I do get it, that it's like, it's rudimentary, fundamental building blocks of reasoning. And if you look at it close enough, you can say there's no way you could come up with reasoning using that building block.
Right.
But part of me says, well, what if there's a Rube Goldberg machine that can solve something? If you put old curtain down, as long as it solves it, does it matter that it was so many small building blocks? Right? It does it, I think sometimes they're getting way better at solving a lot of these things. The pace of innovation is going way up. I don't want us to be like poo-pooers of the technology because it can't solve some puzzle or whatever. Like at some point we got to see the velocity, and we have to absorb the fact that it's accelerating, right? I'm not saying it's there,
Right.
but to dismiss the fact that it might be there in 6 months or 18 months or 24 months,
It's coming.
It feels like it's coming. I feel like it. Yeah. Anyway, I'll stop at that. But I feel like it's coming, and it keeps every barrier we think it can't break, it breaks.
But I mean, you bring up a really important point, and that is instrumentation in these neural networks is incredibly hard, right? It's a black box. Like, we don't really know what's going on inside of it. I think Anthropic does some studies, and they've kind of teased out a little bit, but we don't really know what they're doing.
We don't know what our brains do.
Even when it makes those mistakes, like, they're annoying, right? I've definitely cursed that in as well. But then there's also those happy little accidents that happen. I'm like, oh wow, I never would have thought to tell it to do that, and it just did it.
Yep.
And we were talking about this earlier, Keith and I, and it's actually innovating and being more creative than I would have told it to do.
Mm-hmm.
So that's why sometimes I'm hesitant to get more specific, because I want to give it that opportunity to surprise me, and then I learn from that to refine the product.
Yeah, absolutely. Claude 4 has actually gotten really good at that. As I'm building out stuff in Cursor, sometimes I'll ask it to do something. It'll make suggestions that are sometimes useful, sometimes not. But again, 6 months ago, the models weren't capable of doing that. So it's getting better. All right, let's do a quick recap. Then we're going to wrap this thing up. So today we learned about this LLM fundamentals, how they work. We kind of glazed over that, but we learned enough. Tokens, context, tool functions. To me, that's the most important part. Like, if you all kind of understand how these tool functions work now, to me, that's a win. Agents, we went over those. How many lines of code does it take to create an agent? 2 lines of code, that's right. You can go home tonight, you can create your own agent. You can post about it on LinkedIn tomorrow. Use cases, some of the frameworks, examples, challenges in the future. Did you all get something out of this today?
Yeah,
Is this useful?
Absolutely.
All right, good.
Military background, because you did a very good job presenting that to
Thank you.
something that's complex, making it simple. I've struggled with that in my AI presentations. It's like, oh my God, this is a beast.
It's tough. I mean,
And he showed source code.
Yeah, that's a good point. Yeah.
the challenge for me was, what to leave. There's so much that we didn't talk about, like so much. I mean, we can make this into a 3-day workshop if we want to. Maybe we should. I don't know.
I appreciate that people are getting in front of people and talking about things that we're not none of us are fully sure.
That's right.
But if we don't talk about it, then who's going to know?
Yeah.
And we got to be open to the fact that we're not all Jeffrey Hinton, and we've got to stand in front of someone, and we've got to tell us our experiences and share that so that we all get better, because it's emerging, and that's why I like being here. I like you putting all this together. This is great.
Yeah, thank you. All right, y'all have been amazing. Thank you so much for all the questions and paying attention as we went through all this code. Thank you, guys. And let's give one more thank you to our hosts and sponsors. You guys are awesome to put this on. Thank you. Thank you.